Newton's second law, inertia. Remember, forces are vector quantities, as every force has a magnitude and a direction. Forces are often represented using arrows. The longer the arrow, the greater the magnitude of the force. Forces are measured in newtons. A force can be defined as a push or pull that acts on an object due to the interaction with another object. Resultant force is a single force that can replace a number of forces acting on an object. A resultant force has the same effect as all the original forces acting together. Inertia is an object's resistance to change its state of motion. This means if an object is at rest, it will stay at rest, unless a resultant force acts upon it. If an object is moving with a constant velocity, it will continue to move at a constant velocity, unless a resultant force acts upon it. Inertia describes the tendency of objects to continue to travel at constant velocity or remain in their state of rest. A golfer creates a resultant force to overcome this. If there is a resultant force, there is an acceleration. When the golfer hits the ball, a resultant force is created, and the ball will accelerate toward the hole. If there is a resultant force, then there is also an acceleration. When the golfer hits the ball, a resultant force is created and the ball will accelerate toward the hole, overcoming inertia. If the resultant force is larger, the acceleration will be greater. If the resultant force is larger, the acceleration will be greater. The ball will also have more inertia, so will be harder to stop and slow down. If we use the same force but increase the mass, this makes it harder to move the ball from its current state of motion. Therefore, if an object has a high mass, it has more inertia and becomes difficult to move. This allows us to think of mass in a different way. Mass can now be thought of a measure of how hard it is to change an object moving at constant velocity or an object that is at rest. Mass can also be thought of as the inertial mass of an object. Inertia is the tendency of objects to continue to travel at constant velocity or remain in their state of rest. To overcome this, a resultant force has to be applied to the object. Consider the resultant force needed to move the modes of transportation above. The greater the mass, the more difficult it is to change an object's state of motion. Mass can be thought of a measure of how difficult it is to change an object's state of motion. Hence, scientists also refer to the mass as the inertial mass. We can calculate the resultant force using the following formula. However, we can now use the term inertial mass. Resultant force equals inertial mass times acceleration. We can make inertial mass the subject of the formula. We state our formula resultant force is equal to inertial mass times acceleration. We divide both sides by acceleration, so that acceleration cancels out on the right-hand side of our equation. We simplify and we rearrange, and we are left with inertial mass is equal to resultant force divided by acceleration. Inertial mass is a measure of how difficult it is to change the velocity of an object and is defined as the ratio of force over acceleration. Summary. When a resultant force acts on an object to overcome inertia, the object will accelerate, changing its motion. The greater the inertial mass an object has, the more difficult it is to change its state of motion. Newton's second law can be rewritten as resultant force equals inertial mass times acceleration. Key words: resultant force, a single force that can replace a number of forces acting on an object. A resultant force has the same effect as all the original forces acting together. Inertial mass, the tendency of objects to continue to travel at constant velocity or remain in their state of rest. Inertial mass, the ratio of force over acceleration. Acceleration, the rate of change of velocity.